Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology and Chemistry Lectures. Today I am starting a new topic on nanotechnology. But as this is my first video on nanotechnology, therefore, I would like to give you an introduction to the nanomaterials in this video. Although people say and it is believed that the nanotechnology and nanomaterials are new to the technological field of studies. But I don't believe in it. Why? Because I will say that it is a forgotten science which was used in ancient days, in the ancient history of the world. And I have sufficient evidences to prove it. In this slide, you can see the Damascus sword and the Lycurgus cup. These are the evidences of the use of nanomaterials in ancient world history. So now you can say that this video is going to be an interesting one. Nanotechnology is not only important for scientists and technologists, but everyone should know about the nanomaterials because we all are stakeholders. We all are using nanomaterials in our day-to-day life consumer products in the form of hand wash, sunscreen lotions and creams, stain resistant merchandise, clothings, wrinkle-free textiles, sports good, and so many things. So, because I am making this video for everyone, therefore I have tried to make it in a very simple and interesting way. Not in the form of a book or a lecture, but in the form of questions and answers along with illustrations for your better understanding. So, if you have not subscribed to my channel, please subscribe to it to get more such informative videos on nanotechnology. And also don't forget to share it among your friends. Let's now begin with the nanotechnology, an introduction to nanomaterials. So when we are talking about nanomaterials, we should first know what nanomaterials are. Nano means very small, smaller than micro. So if you want to understand it in a layman language, let's take a lump of koila, crush it and break it into small pieces. So the big lump is macromolecule. If you break it into small pieces, it will come into micromolecules, and when you grind it, it becomes powder. So then it comes to nanoscale. So now you can at least imagine what nano is. And here is the figure. This is a big piece of coal. When it is crushed into pieces, it has come to micro level. Further grinding it, it becomes powder. So what are nanomaterials? nanomaterials are considered to be the materials which at least has one dimension that measures 100 nanometers or less than it. They could be in the form of particles, tubes, rods or fibers. Then what is nanotechnology? Explain in simple language. The branch of science and engineering in which we study the nanoscale materials is called nanotechnology. It is devoted to designing, producing and using structures, devices and systems by manipulating atoms and molecules at nanoscale. Is nanometer smaller than micrometer? Yes, nanometer is smaller than micrometer. 1 nanometer is 1000 times smaller than a micrometer. 1 micrometer is equal to 100 nanometers. What are the various units of conversion? So here I have given the various units of conversion. You can go through it. But I would like to see this figure where I have tried to explain the scale in which you can imagine the size of the nanomaterials. So nanomaterials are designated by nm, micromaterials by μm. This is millimeter, centimeter and then meter. I have not taken kilometer. So now you can see that the atoms, they fall under the nanometer scale. The bacteria, they come under the micrometer scale. So nanometer is smaller than the micrometer. I have explained it here. Similarly, the ants, the insects, the houseflies, they come in the millimeter category. So millimeter is bigger than micrometer. A tennis ball, you guys play with the tennis ball and it is measured in centimeters. And then you can see the aeroplane which is measured in meters. So where does the nanomaterials come or fall? In which scale? In the nanometer scale. Does the properties of materials same at bulk and nanoscale? No, they are not same. At nanoscale, unique properties of the materials emerge. And these properties are different from their bulk molecules. Bulk means large. Thus making the nanomaterials very, very interesting. For example, all of you know gold. What is the color of gold? It is yellow. Golden yellow you can see. But that golden yellow color of gold is at the bulk scale. That is at a large, when the gold is in large quantities. But the same gold, when it is brought to nanoscale dimensions, it shows blood red color. So, the optical properties of gold at bulk scale is yellow. But at nanoscale, the same gold is showing blood red color. So, in short, what we can say? That the material's characteristics such as color, strength, conductivity. That is, conductivity means the movement of electrons, and reactivity all differ substantially between the nanoscale and at macro scale. Carbon nanotubes CNT are 100 times stronger than steel but 6 times lighter than steel. And here is the figure of carbon nanotube CNT. What properties of nanomaterials are so important and finds application in various fields. The properties such as optical, I have already described to you with the help of gold, magnetic, electrical, mechanical and physical properties of nanomaterials are extremely important. These properties have great potential in various fields of science and technology, medicine and agriculture, space and aeronautics, geo-ocean sciences and military. So we can say that the nanomaterials and its applications are important for all walks of life. Does naturally occurring nanomaterials exist? If yes, give examples. Yes, the naturally occurring nanomaterials, they exist and were found in early meteorites in soot. Soot means kajal, and in seashells. So I have put the image of one seashell here. How nanomaterials classified on the basis of existence? On the basis of existence, nanomaterials are classified into two types: natural and engineered nanomaterials. Engineered nanomaterials means man-made and they are abbreviated as EN. What are the applications of engineered nanomaterials in real life? They are used in everyday consumer products. For example, the nanomaterials of silver are used in hand washes, bandages, socks to deliver antimicrobial properties. And this is the reason when there was the epidemic due to corona, we were advised to wash our hands frequently using hand wash to get rid of the virus. Other than this, zinc and titanium nanoparticles are used as active UV protective elements in modern sunscreens, lotions and creams, cosmetics, in stain resistant textiles. If something falls on your clothing, you just wash it. There will be no stain of the food or the thing which is spilled on your clothing. Stain resistant comes through nanomaterials used in the textiles and clothings, the wrinkle free textiles, sports goods, varnish and paints, electronics goods and in agricultural products. Everywhere we find the use of nanomaterials. Give some examples to imagine the size of a nanomaterial. So, to imagine the size of a nanomaterial, let us first take a sheet of paper. A single sheet of paper is so thin, but do you know that this single sheet of paper is 100,000 nanometers thick? 100,000 nanometers thick. That means it is very thick compared to the nanomaterial. A single sheet of paper. A strand of human DNA is around 2.5 nanometers in diameter. There are 25 lakhs and 400,000 nanometers in 1 inch. A human hair is approximately 80,000 to 100,000 nanometers wide. A single gold atom is about a third of a nanometer in diameter. On a comparative scale, if the diameter of a marble, the glass balls with which the kids play, was 1 nanometer, then the diameter of the earth would be about 1 meter. And now I will give you another interesting example to imagine the size of nanometer. That 1 nanometer is about as long as your finger nail grows in 1 second. That is nanometer. Who is called the father of modern nanotechnology? Why I am saying modern? Because nanotechnology was there in the ancient times, but it was forgotten in the Middle Ages. So Richard Phillips Feynman is called the father of nanotechnology. He was a renowned theoretical physicist and a well-known American scientist. He was also a Nobel laureate. Who said there is plenty of room at the bottom? It was Richard Phillips Feynman in his most famous talk at Caltech on December the 29th, 1959, where he described his idea on top-down technology titled "There is plenty of room at the bottom." And to dedicate this slide to the father of nanotechnology, I have given the title of this slide as "There is plenty of room at the bottom." That means take a lump of coal, crush it, bring it to microparticle size, grind it to a fine powder and get the nanoparticles, nanomaterials. So top-down technique. Who coined the word nanotechnology? The word nanotechnology was coined by Norio Taniguchi of Tokyo Science University in 1974. Almost after the 15 years of the famous talk by Richard Phillips Feynman, there is plenty of room at the bottom. Who defined nanotechnology? Give the definition and state the basis of his definition. The definition of nanotechnology was given by Norio Taniguchi, which still holds good. He described the thin film deposition in the semiconductor processes to be in the order of nanometers and defined nanotechnology as nanotechnology mainly consists of the processing of separation, consolidation and deformation of materials by one atom or one molecule. Who used the word nanotechnology and when? It was K. Eric Drexler who used the word nanotechnology in 1986 in his book Engines of Creation, the Coming Era of Nanotechnology. With this emerged the nanotechnology as a promising field of the modern era, and therefore I have written at the top that till 1980s nanotechnology was not an established field. It was in 1986 when the nanotechnology actually emerged as a promising field. By whom was K. Eric Drexler inspired? He was inspired by the father of nanotechnology, none other than Richard Phillips Feynman concepts. Invention of which instruments and materials were a landmark in the discovery of nanomaterials? Invention of scanning tunneling microscope in 1981, followed by the discovery of fullerenes in 1985, were the major breakthroughs in this area, because fullerenes are nanomaterials. How does nanomaterials contribute to modern day technology? The discoveries of nanomaterials is a big revolution in the modern age as it finds applications everywhere in industries, in engineering, basic sciences, research and development, medicine and health, agriculture and textiles. Everywhere the nanomaterials and nanotechnologies is used. What is graphene? Is it a nanomaterial? Yes, graphene is a unique nanomaterial made up of one atom thick transparent sheet of carbon. What are the applications of graphenes? They are employed in manufacturing carbon nanotubes, also called bucky tubes. Its discovery revolutionized the electronics and optical industries and other fields of material sciences. What is nanoscale? Conventionally, nanotechnology is taken as the scale range of 1 to 100 nanometers, following the definition used by the National Nanotechnology Initiative in the US. What is nanometer? Nanometer is a unit of measurement in metric system. 1 nanometer is described as 1 billionth of a meter. That is 10 to the power of minus 9 meters. Where is nanometer used? Nanometers are used to measure wavelengths of light and distances between atoms in molecules. Now we should also remember that 1 nanometer is described as 1 billionth or 10 to the power of minus 9 of a meter, which is 1,000th of a micrometer. That means that nanometer is smaller than a micrometer. The angstrom is not used nowadays. It has been superseded by nanometer, which is 10 times larger than angstroms. So angstroms is smaller than nanometers, which is in turn is smaller than micrometer. 1 nanometer is equal to 10 angstrom, which is equal to 10 to the power of minus 9 meters. The space between a carbon-carbon bond lies between 0.12 to 0.15 nanometers. Similarly, a DNA double helix molecule has a diameter of around 2 nanometers. The bacteria of genus Mycoplasma are around 200 nanometers in length. So here, with the help of images also, I have depicted the size and length of various molecules. The DNA double helix molecule with a 2 nanometer diameter, the carbon-carbon single, double and triple bond are shown here, and the size of various cells also are depicted in this image. With the help of figure, illustrate the size and scale of nanomaterials. So here in this slide, I have tried to further make you understand the size and scale of nanomaterials. Here is a arrow. On the top of this arrow are the scales written in angstrom, nanometers, micrometers, millimeter and centimeter. Below the arrow is written in the meter on 10 to the power. So you can see here that the atoms, they are only 1 angstrom and smallest. Then coming to the molecules, they fall in 1 nanometer length scale dimensions. DNA molecules 10 nanometer. Viruses 100 nanometers. And then comes bacteria, which comes under the micrometer capacity. The human hair, which is very, very thin, but it is around 100 micrometer. Then comes ant, and then comes the tennis ball. So, here you can see there is a yellow patch. Beyond this yellow patch comes the micrometer. So, we have already learned that the nanomaterials falls under 100 nanometers scale. Anything which is more than 100 nanometers does not fall in the nanometer scale and cannot be a nanomaterial. How are nanomaterials defined? Nanomaterials are defined as substances where at least one of the dimensions should be less than approximately 100 nanometers. So, now we can say that anything which has a dimension more than 100 nanometers cannot be a nanomaterial. How are nanomaterials classified? Nanomaterials are classified on the basis of dimensions, where at least one of the dimensions, the material, should be less than 100 nanometers. According to this, we can classify it as a zero dimension. Examples are spheres and clusters, and here I have shown with the help of this image, this is fullerene, which is spherical in shape, rounded in shape. So it has a zero dimension. Then one dimension. Examples are wires and rods. You can see in this figure also. These are spherical or clusters. These are zero dimension. Then it comes one dimension, the rods and wires. Two dimensions, films and plates. So films and coats, plates are two dimensional. And then three dimensional, particles and crystals. So this is three dimensional, where you can see the polycrystals. So in this way we can classify the nanomaterials based on the dimensions. In what forms and shapes does nanomaterials exist? They can exist in single, fused or in aggregated forms with spherical, tubular and irregular shapes as per the requirement of the applications. Why nanotechnology gaining momentum in industries? Nanomaterials have great potential in all areas. It increases the efficiency of energy consumption, helps in keeping the environment clean, in the drug delivery and removal of toxins from human body. In addition to all these, the products of nanotechnologies is very small, cheap, light and more functional and require less energy and less raw materials to manufacture. Therefore, it is gaining momentum. Give the average bond length of single, double and triple bonds in molecules. So here in the table, you can go through the various single, double and triple bonds with carbon, 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 nitrogen, carbon, oxygen atoms. Is there significant evidence of use of nanomaterials in ancient history? Yes, there are many examples of use of nanomaterials. We'll start with the Lycurgus cup, which is an example of use of nanotechnology in Roman Empire, where silver and gold nanoparticles were used with ceramics. The silver nanoparticles, they showed green color in the normal light, but the same cup, when lit from behind, showed the blood red color. So this is the same cup. When it is kept in the normal light, it is showing the green color due to the presence of silver nanomaterials in the ceramics. But the same cup, when it is lit from behind, from the back side, it shows blood red color. And this mystery remained unsolved till 1990 because we were not having the knowledge of nanomaterials. The 17th century Damascus sword is another such example, which contained carbon nanotubes and nanowires to give it a legendary strength. It is believed that the Damascus sword had very high flexibility and the edge was very sharp. It could cut the linen in the air. The steel with which the sword was made was called the wood's steel, and it was imported from southern India to Damascus weapon industry. The legendary sword of Tipu Sultan in National Museum, New Delhi is also made up of wood's steel. Dr. Sharda Srinivasan and Dr. Ranganathan Srinivasan of National Institute of Advanced Studies, Bangalore, have worked extensively on the history, origin and chemistry of wood's steel and has given insights on it. Dr. Srinivasan has mentioned that Mughals, Rajputs, Nizams, Tipu Sultan, Mysore Wadiyars and Tanjore kings, all of them had Damascus swords in their armory. T. L. Love, a researcher from University of California, Berkeley, has written that in many Sanskrit texts of 7th to 13th centuries on alchemy and chemistry of the Indian subcontinent has described the processing of plants and minerals in closed crucibles to produce steels, because the plants and minerals attribute to the nanomaterials. And this evidence is true because many researchers have published papers on the preparation of nanomaterials, especially the zinc nanoparticles from sacred basil, the tulsi. So, in the beginning of this video, I was telling you that there are many evidences of the knowledge of nanotechnology and use of nanomaterials in the ancient history. And these evidences prove that yes, it is true that the ancient people were very much advanced and were using nanomaterials and nanotechnology in their day-to-day life. There is lot to learn more about nanotechnology. So it will be continued in the upcoming videos. Keep watching for further details. And if you have liked my way of teaching, please don't hesitate to like this video and also leave your view, your opinion on this video in the comment box.